Webb begins a voyage back to the birth of the universe.
Really think about someone saying, let's invent a telescope that can see back to the Big Bang. Like, what?
On the morning of December 25th, 2021, the ground in French Guiana trembled as the powerful rockets of the Ariane 5 launch vehicle fired up. This deafening roar began the incredible journey of the James Webb Space Telescope, flying it into space and almost 1 million miles away from Earth.
Liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
The new $10 billion James Webb Space Telescope, the ultimate holiday light display.
James Webb now has its array out.
We are going to discover incredible things that we never imagined.
It wasn't an instant success, though. After reaching its new home in space, scientists and engineers worked for 6.5 more months to make the massive 6.5-meter telescope fully operational. However, the wait was worth it, as the James Webb Space Telescope has revolutionized our understanding of the universe since it became operational.
We've gone from basically ignorance about what that first billion years of the universe was like to having it in crisp, high definition.
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
The James Webb Telescope sent back breathtaking images and groundbreaking data from stars and planets close to home to ancient galaxies formed billions of years ago. This powerful telescope also revealed secrets hidden in the cosmos, thanks to its clearer and more detailed pictures, unlike its legendary predecessor, the Hubble Space Telescope. From Stephan's Quintet to the Pillars of Creation, these are the most amazing discoveries made by James Webb Space Telescope. Stephan's Quintet, a dance of galaxies. One of the first breathtaking images captured by the James Webb Space Telescope was of a group of galaxies called Stephan's Quintet. At first glance, it looks like 5 galaxies are joined together, but only 4 interact. The 5th one is much closer to us and appears in the same view. Scientists are especially interested in groups like Stephan's Quintet because they show how galaxies pull on each other with their gravity, sometimes even merging together. Long ago, these kinds of mergers were common in the early universe. In fact, they played a big role in forming the giant galaxies we see today. When galaxies interact, they can trigger the birth of new stars and even feed black holes. In this group, the galaxy known as NGC 7319 contains a supermassive black hole with a mind-blowing mass about 24 million times that of our Sun. Thanks to Webb's sharp vision, scientists can now study these cosmic collisions like never before. But there's even more. Bright galaxies at the dawn of time. Before the James Webb Space Telescope, scientists thought galaxies started small, slowly growing over billions of years. This would seem reasonable because we believe our universe is still expanding. But Webb's powerful infrared vision has given us a deeper look into space and even back in time than ever before. What it has found is shocking. Some of the earliest galaxies, formed within just 500 million years of the Big Bang, are much brighter than anyone expected. This could mean a few things. Maybe these galaxies are making stars much faster than predicted, or perhaps they are far more massive than scientists thought was possible at such an early stage. Webb has also revealed surprisingly complex structures in some spiral galaxies that existed during cosmic noon, when the universe was around 2 to 3 billion years old and forming stars at its fastest rate. These discoveries are forcing astronomers to rethink how galaxies grew in the early universe and how quickly they became the giant star factories we see today. Speaking about giants, we now know there is mysterious giant black holes in the early universe. We know black holes grow by swallowing stars, gas, and dust over time. So it was a huge surprise when the James Webb Space Telescope found very big black holes, some 1 billion times the mass of our Sun, just 800 million years after the Big Bang. That's not a lot of time for them to get so big. Even more shocking, Webb has also spotted smaller supermassive black holes, with masses between 1 million and tens of millions of suns from earlier periods. These discoveries could help scientists finally understand how these cosmic giants form and grow. Do they start small and gradually build up, Or have some black holes been born much larger than we expected? With Webb's data, astronomers are closer than ever to solving this deep space mystery, just like they are with solving the puzzle of the Pillars of Creation. The Pillars of Creation, a breathtaking part of the Ring Nebula, is a vast region where new stars are being born. You may have seen the famous Hubble Space Telescope image of these gigantic dark clouds of gas and dust standing against a colorful cosmic backdrop. But the James Webb Space Telescope has taken it to the next level. One of Webb's biggest discoveries in this region is the presence of young, glowing red protostars. These are baby stars still forming inside the gas and dust, not yet hot enough to burn hydrogen in their cores. Before Webb, they were completely hidden behind thick clouds, invisible to Hubble's powerful eyes. But with its ability to see through dust, Webb has opened a new window into this star-making factory, located about 7,000 light-years from Earth. Next up is HIP 65426b, a distant giant caught on camera. Astronomers have discovered thousands of exoplanets, but actually seeing them is incredibly difficult. The reason? These distant worlds are hidden under the shadows by the bright light of their parent stars. However, the James Webb Space Telescope has managed to do what few telescopes before it could: capture a direct image of an exoplanet. The planet HIP 65426b is a massive gas giant, about 6 times the size of Jupiter. To give you a better understanding, Jupiter is so big that 1,300 Earths could fit inside of it. HIP 65426b orbits its star at a great distance, about 100 times farther than Earth is from the Sun. This makes it unlikely to be a place where life could exist, but Webb's ability to photograph it is a real achievement. The telescope used a special tool called a coronagraph, which blocks out the star's light, making the planet visible. Even very small objects and things have become visible with the help of this telescope, like a tiny asteroid, JWST's smallest discovery yet. While the James Webb Space Telescope is famous for spotting distant galaxies and exoplanets, it has also surprised scientists by making an unexpected discovery much closer to home. In February 2023, the telescope noticed a tiny asteroid hiding in the asteroid belt between Mars and Jupiter. This small space rock is about the same height as the Washington Monument and is thought to be a leftover piece from the formation of our solar system. Studying it could give scientists valuable clues about how planets and asteroids formed billions of years ago. Finding asteroids this small is incredibly difficult with other telescopes, which makes this discovery even more exciting. And for something more exciting, ancient cosmic dust, a surprising early arrival. Dust is everywhere, in the air we breathe, under our beds, and floating through space. In astronomy, dust plays a crucial role in forming stars and planets. Most cosmic dust contains carbon, which wasn't present in the early universe. Before spreading into space, it had to be created inside the first generations of stars. That's why scientists were shocked when the James Webb Space Telescope found dust in a galaxy that existed just 1 billion years after the Big Bang. Even more surprising, this dust appears to have a unique chemical makeup, possibly containing graphite or diamond-like grains. These findings suggest that the earliest stars might have produced dust much faster than expected. This totally changes what we know about how galaxies formed in the young universe and possibly changes what we know about much more. The expanding universe. A cosmic puzzle gets more confusing. One of the most important numbers in astronomy is the Hubble constant, which measures how fast the universe is expanding. But there's a problem. Scientists keep getting different answers depending on how they measure it. The European Space Agency's Planck spacecraft calculated the expansion rate at 67 kilometers per second per megaparsec using cosmic background radiation. However, measurements of certain stars and supernovae taken with the Hubble Space Telescope give a higher value. This disagreement is known as the Hubble tension. The James Webb Space Telescope has confirmed the higher number with even greater accuracy. This means something big might be missing from our understanding of the universe. Either scientists have overlooked an important part of cosmic physics, or their measurements have hidden errors that just happen to point in the same direction. However, instead of providing a clear answer, Webb's data has made things even more complicated, The disagreement between models and observations remains, raising new questions about our understanding of the universe. Could this mean something is missing in our theories of physics? Or is there an unknown factor influencing the expansion of space? The mystery of the Hubble constant continues. For now, scientists are left searching for answers. Next up, unveiling the secrets of star formation. Stars are born inside thick clouds of gas and dust, but this dust blocks visible light, making it hard for astronomers to see the process in detail. That's where the James Webb Space Telescope comes in. Since it detects infrared light, which can pass through dust, Webb has revealed newborn stars hidden deep inside star-forming regions. For example, in the Eagle Nebula, also known as M16, Webb has uncovered thousands of completely invisible stars in the Hubble Space Telescope. It also provides a stunningly detailed view of the nearby Rho Ophiuchi complex, where dozens of small young stars form. Webb's images even capture jets of material shooting from these infant stars, lighting up clouds of molecular hydrogen around them. These discoveries give scientists a clearer picture of how stars come to life. Still speaking about stars, Webb Space Telescope has discovered WR-140, a star wrapped in mysterious cosmic rings. Among Webb's most unusual images is one of a star called WR-140, a type of Wolf-Rayet star known for being extremely hot and filled with elements like helium, nitrogen, and carbon. But what makes this star truly fascinating is the strange series of rings surrounding it. At first glance, these rings might seem like a glitch in the telescope's imaging, but astronomers confirm they are real. But guess what's even more incredible? WR-140 isn't alone. It's part of a double star system. So you're wondering, what does this mean? Every 8 years, as the two stars get closest to each other, their powerful stellar winds collide, pushing out waves of gas and dust. Over time, these waves form distinct shells that expand outward, like ripples in a pond. Webb's sharp vision has allowed scientists to count 17 of these shells, revealing over 130 years of cosmic dust production. Still, on Cosmic Discussion, we can now see something spectacular, all thanks to the James Webb Space Telescope. What's that? The cosmic cliffs. One of the most breathtaking images captured by the James Webb Space Telescope is the cosmic cliffs, a massive cloud of gas and dust in the Ring Nebula, about 7,500 light-years from Earth. This region got its nickname because the towering dust formations resemble a rugged mountain range. But these cliffs are far from solid. They are clouds of cosmic dust slowly eroded by the intense ultraviolet radiation from newly formed stars. What appears to be steam rising from these celestial peaks is hot, ionized gas and dust blown away by powerful stellar winds. Thanks to Webb's ability to see through thick cosmic dust, it has revealed countless young stars hidden deep within this nebula. The stunning image from the James Webb Space Telescope reveals the universe's beauty and helps scientists understand how stars are born in such environments. Next up, Cassiopeia A, a supernova's dusty legacy. Light from a massive star explosion reached Earth about 340 years ago. Today, Cassiopeia A, a supernova remnant stretching 10 light-years across, remains what remains of that explosion. This giant cloud of dirt glows in infrared light, which reveals delicate wisps of gas and a soft, dusty glow that intrigues astronomers. Cosmic dust plays a crucial role in forming planets and even life itself. Scientists believe much of this dust comes from supernovae, which eject heavy elements into space. However, previous studies couldn't fully explain why there was so much dust in the early universe. By studying Cassiopeia A in greater detail, the James Webb Space Telescope is helping scientists uncover how these massive star explosions contribute to the cosmic materials that shape galaxies, planets, and possibly even the building blocks of life. Speaking about formation, we can now see a jumbo-sized mystery in the Orion Nebula. Deep within the Orion Nebula, also known as M42, astronomers have made a discovery that defies everything they thought they knew about planetary formation. Using the James Webb Space Telescope, scientists found at least 40 planet-sized objects paired together in binary systems. These strange pairs, called jumbos, short for Jupiter Mass Binary Objects, challenge existing theories about how celestial bodies form. Normally, stars often have companion stars, but astronomers never expected planetary mass objects to have them too. The mystery deepens because current star formation theories don't explain how objects this small could form on their own. And if they were created like planets in a star's disk and then thrown out, they should have been destroyed in the process. This discovery suggests that scientists may need to develop new theories on how planets and stars form. This is a total revolution, all thanks to the telescope, the JWST, and the hunt for elusive dark stars. In July 2023, astronomers announced that the James Webb Space Telescope might have found something never seen before: dark stars. These mysterious objects, first theorized decades ago, are believed to be powered not by nuclear fusion like ordinary stars, but by dark matter, the invisible substance that makes up most of the universe's mass. At first, Webb identified these three objects as galaxies in 2022, but further analysis suggests they might be something far stranger. If dark stars exist, they could help explain how the universe's first structures grew so quickly after the Big Bang. This discovery is still being debated, but if confirmed, it would change our understanding of dark matter and the earliest days of the cosmos. A new era in exoplanet exploration. Among the James Webb Space Telescope's most exciting discoveries are its groundbreaking studies of exoplanets, planets orbiting stars outside our solar system. One of the most fascinating finds is K2-18b, a distant world located 120 light-years from Earth in the habitable zone of a cool dwarf star. This means it's at the right distance from its star for liquid water to exist, making it a prime candidate in the search for alien life. While Webb's stunning images capture the public's attention, its ability to analyze light through spectroscopy is what truly changes the game. Scientists can detect the presence of different molecules by studying how light interacts with an exoplanet's atmosphere. On K2-18b, Webb has identified methane, carbon dioxide, and even dimethyl sulfide, a compound that, on Earth, is mostly produced by living organisms in the ocean. This suggests the planet might have a water ocean beneath its thick atmosphere. This will surely make it one of the most intriguing exoplanets ever discovered. While more research is needed, these findings push us closer than ever to answering one of humanity's biggest questions: are we alone in the universe? We do not exactly actually, but what the James Webb Space Telescope helps to know is the existence of rings within rings, a stunning new look at the Ring Nebula. The Ring Nebula, M57, in the constellation Lyra has long been one of the most striking planetary nebulae in the sky. It represents a sun-like star's final stage, as it sheds its outer layers and forms a glowing gas shell. But the James Webb Space Telescope has revealed even more stunning details within this cosmic masterpiece. Webb's observations show that the nebula's main ring is made up of 20,000 clumps of molecular hydrogen, adding incredible depth and texture to what was once thought to be a relatively smooth structure. However, the real surprise lies beyond the ring. Webb has detected a series of 10 concentric arcs extending outward. Astronomers believe these arcs formed when gas ejected from the dying star interacted with a hidden companion star, orbiting at a distance similar to that between the Sun and Pluto. This discovery sheds light on how stars like our Sun evolve and shape their surroundings even in their final moments. Protoplanetary Discs. Another one of the James Webb Space Telescope's most exciting discoveries is its ability to peer deep into protoplanetary discs, the swirling clouds of gas and dust around young stars where planets are born. These observations reveal not just how planets form but also provide hints about the origins of life itself. For example, around the nearby star Fomalhaut, Webb found 3 nested belts of warm dust, which suggests the presence of planets sculpting the disk. In the star system PDS-70, Webb detected water vapor in the inner disk, which shows that any rocky planets forming there would have access to water, a key ingredient for life. Does that mean there could be some sort of life there? Well, scientists are still hunting for proof. However, perhaps the most groundbreaking finding comes from the protoplanetary disk around the young star D203-506, located in the Orion Nebula. There, Webb discovered the methylcation, a molecule that is crucial in organic chemistry. This discovery could help scientists better understand how the building blocks of life form in space, bringing us closer to unraveling the mystery of life's cosmic origins. So, which of these discoveries truly blew your mind? Are you excited about what we could find with the James Webb Space Telescope? Let us know your thoughts in the comments below.